all right. Lucy will let us know.
All right, you're live.
All right, here we are. Thanks for bearing with us while we figured out some technical difficulties here on the ground in Mason, Texas. I'm Kelso Harper. I'm a multimedia editor here at Scientific American, here with Clara.
I'm Clara Moskowitz. I'm a space and physics senior editor at the magazine.
Yeah, we're really excited to be here in Mason. We finally found a spot with decently clear skies. There's a little bit of cloud cover here. You might see it in the close-up view of the sun, but we're hoping that it'll be clear around totality. It's been kind of a journey to get here, though.
Oh, it's been suspenseful. We've been looking all over the map in Texas, trying to decide which direction to drive till we found sun. We're really feeling hopeful, but it could go any way.
There's a bit of a breeze in the air, kind of an ominous breeze, but and I know there's supposed to be storms later, but we're holding out hope that it'll work out for us.
Yeah, absolutely.
It was actually interesting. I learned a lot about weather on the way here. The app we ended up using was called Windy, and it was excellent. So if you're ever trying to find out, chase an eclipse in the future, Windy was great. It has a bunch of different models you can find.
Yeah, we learned about clouds. We learned that for eclipse watching, low clouds are bad, high clouds might be okay. So that's what we're really keeping an eye on.
Right. As the air cools during totality, some of the high clouds might even clear. Lower clouds probably wouldn't, though. Do we have any questions, Sonia, that we can get started on?
Yes, question. How long until the eclipse begins? And what happens once it starts?
Yeah.
So the totality here in Mason begins at 1:33. So we've got a nice little show of the partial eclipse. You'll see the moon taking an ever larger bite out of the sun. Right now we've got a nice little Pac-Man, and it's going to grow. The mouth is going to get bigger and bigger and bigger until, like I said, 1:33, we're going to begin totality. There's going to be about 3.5 minutes of totality here.
I think we'll have like 3 minutes and 52 seconds, which is decent. You know, another person here with us has seen totality a couple times, but nothing more than 2 minutes. So that's actually quite long in the range of totality. The eclipse actually started, like the moon started to cover the sun at about 12:16, I believe. So it's an hour and 15 minutes from the start to when totality begins. I've never seen a total solar eclipse. This will be my first time. I've heard amazing things. Clara has experienced one before.
This will be my second time. So I'm still a newbie, but once you see one, you become committed to seeing as many as you can.
I haven't even seen one yet, but just hearing from Clara and our other expert, Kate Russo, who was on our last live stream, I feel like I'm already ready to be a chaser even without seeing them.
We are. So let's talk to you about what's going to come up. Once totality begins, that is one of the most exciting moments of the whole show, is that transition into totality, because we see what's called Bailey's beads. And these are beads of sunlight, the very last beads of the sun left before the moon completely covers its face. And those beads shine through because the moon does not have a flat, rounded surface. It's actually got craters and mountains. It's quite a rugged edge. And that rugged edge lets little beads of sunlight through, whereas in other places it's blocked. So it's
just bananas to me. The fact that we can see the light through the craters on the moon.
The craters on the moon. It's a stunning effect. And then you get what's called the diamond ring, which is the very last final single bead left, and the light spreads a little bit around it, looking like the band of a ring, and that bead is the diamond itself.
And what will we see when totality actually happens? Like, what will we actually be looking like when we take off our eclipse glasses and can actually look at what's happening?
Exactly. So as that transition to totality is happening, amazing things are happening around us. So we will feel the air get cooler as the sun becomes fully covered up. We will see the sky darken until it's pitch black, like in the middle of the night. A lot of animals get confused, nighttime animals like bats might come out. We'll have to see what happens, but you'll really notice a full body sensation. And then when the sun is completely blocked by the perfect face of the moon, that's when we see what's called the corona. It's this white wispy light, that sort of ethereal glow coming off around the sun. And what that is the sun's atmosphere, which we normally can't see because the face of the sun is so much brighter. But when that's not there, we can see this really cool phenomenon of the corona.
I think that's one of the things I'm most excited about. Like, I didn't know I would ever be able to see the corona until I started learning all about eclipses recently.
Right, and
Yeah.
the corona is just this amazing physics phenomenon that scientists are still trying to understand, and they're actually going to be running a lot of experiments during this eclipse because it's this rare chance to see the corona, to see a great view of it and study it that
Right.
we usually can't do.
What are scientists hoping to learn during this eclipse?
So one of the weirdest things about the corona is that it's really hot, way hotter than the surface of the sun, which is very counterintuitive because you're coming from a very hot thing and then you're moving outward. You would expect it to cool off, but instead it heats up as you move outward from the surface of the sun.
Wow.
And scientists think that this must have to do with the magnetic field of the sun, but they don't know the exact physics involved. It's very complex and dynamic, and they really want to understand how that heat transfer is happening.
Cool. Should we take another question?
Yeah, actually, two kind of related questions. One is about what folks are seeing on this split screen.
Yep.
And the second, a lot of people saw our video on how to, actually watch the eclipse.
Yeah.
There's a lot of questions about what's dangerous, what's not. How do you view an eclipse safely?
Yes.
Okay.
Huge.
Yes.
Sarah, go take it away.
So, right, let's talk about safety.
In fact,
So,
I'm going to take a quick
me
peek.
too. So here we are with our eclipse glasses. Look at that.
They look very cool, very snazzy. They are not 3D glasses, even though they
Right.
might look like them.
Right. So what this is very similar to welder's glass. It blocks out almost all light except for the very brightest lights and the sun itself. So when you put these on, you see darkness. I don't see anything at all unless I look up at the sun. That's the only thing I can see. So these are very important because these are blocking the sun's light from directly hitting my eye. During the partial, what we're seeing right now, where the moon is taking a bite out of the sun, that's when you need these. Now, once we get to totality, that's where you can take them off because totality is when none of the sun itself is visible. Only the corona. The corona cannot hurt your eyes. That's just the wispy white atmosphere. So once you see that it's full totality, which you will know because the face of the sun will be black, surrounded by a crown of white, surrounded by a black sky. And actually, it'll go dark in your eclipse glasses. You'll know it's time to take them off because you won't be able to see the partial eclipse anymore. And you take them off and in your naked eye can behold the glorious eclipse. And that is totally safe. You are fine. But as totality is ending, as you start to see the Bailey's beads again on the other side, that's when it's time to put your glasses back on and prepare your eyes.
Because it doesn't take long for the light from the sun to your lens to focus it on your retina, and it produces all these chemicals and free radicals, and those damage the cells in the back of your eye, and you can be left with a blind spot. So you really don't want that. So really only look through these. Or if you don't have them on hand, you can use a colander to look at the shadows of the partial eclipse as it goes over, or anything with small holes. You can put a small hole in a piece of paper, hold it up and look at the shadow on the ground, and that'll show you where in the partial eclipse you are.
Even tree leaves. So if you've got a nice tree with lots of leaves on it, they create little holes where the light can come through and they cast shadows, and you can look on the ground under a tree and see the shape of the eclipse, which is awesome.
Yeah.
Where are we right now? A lot of folks are wondering. And what are you showing us?
Oh yes, we're on the ground in Mason, Texas. It's a little bit northwest of San Antonio, pretty close to the center of the path of totality. And what you're seeing right now, we've got behind us Lucy, our fabulous videographer, can wave. Here we go. We have a camera with a 600 millimeter lens on a star tracker, which is actually tracking the movement of the sun in the sky and keeping it in the center of the frame. And right now, it looks like we're not even quite to halfway of the partial eclipse. So the moon is, we're just getting a nice little Pac-Man bite out of the sun at the moment.
Beautiful.
So you're seeing us on the ground and seeing a close-up of the sun from the camera right behind us.
Right, exactly. So you're going to keep seeing the whole eclipse. We're going to keep streaming to you as we get into totality with Lucy's awesome setup. You're going to see everything.
We're only going to we'll do questions until we run out of questions or want to hop off, and then we'll keep you going on the live stream so you get the close-up of the sun throughout the whole eclipse.
Yeah. And we picked this location in the last couple hours.
Yeah.
We have been driving all over Texas in search of clear skies. This is where we thought we had a good chance. It's still touch and go. We're crossing our fingers real hard and our toes.
But I mean, I'm just really excited to be here, and the energy here is amazing. There's tons of people with different telescopes and cameras set up, but people are just excited. When the partial eclipse began, there was a big cheer from everyone. The energy is fantastic.
People yelled out, "First contact!"
First contact.
That means the first moment of contact between the sun and the moon.
Yeah.
And that was. I couldn't see it though for another minute or two.
Right. Yeah. Just the first bite.
Yeah.
What else we have, Sonia?
Are there any experiments folks can do while watching the eclipse?
That's a good question.
Absolutely, yes. So like I said, the eclipse is a great opportunity for science, and researchers need your help. There's a lot of projects that are looking for people anywhere along the path of totality to participate. One of them is called Sun Sketcher. You can download this app on your phone, and as you approach totality, you set up your phone and point it toward the sun. You press a few buttons and you leave it alone, and it's going to take photos of the sun, and it's going to combine those photos with those taken from other people's phones all along the country, all along the path. And the goal is to try to make a measurement of the shape of the sun. Now, we all know the shape of the sun is round. However, it's not perfectly round. It's actually a little bit off round. And if they can measure those deviations from being perfectly spherical, scientists can understand the physics inside the sun driving that shape. And this is hopefully going to be the most precise measurement ever made of the shape of the sun.
Right.
And there's some other cool projects. There's one called Soundscapes, which is actually studying what happens on Earth to people and animals and insects during the eclipse. Because like I said, it's such a bewildering experience for us and for all creatures on Earth, for the sun to go dark in the middle of the day, for the sky to get black and cold, and they want to understand more how that affects all the animals and people.
Yeah, I believe there's a research group at a zoo somewhere nearby in Texas who's doing another experiment similar to the one that they did in 2017 at a zoo in South Carolina, where they're observing different species in the zoo to see how they react. Some animals don't seem to care. Some seem to think that night is falling and will do anything they would normally do when night is falling, but in a shorter time span. And others do have like kind of an anxious response where they seem to be running around or just having anxious behavior. So it'll be interesting to see what we learn from this eclipse too.
Yeah, there's a big bat colony near here that scientists are going to be specifically keeping an eye on.
Yep. What else, Sonia?
Actually, a lot of people were asking about animals.
Okay, great. Yeah.
If the temperature might change, and if that actually impacts viewing, some folks are saying it seems like maybe it's a bit windy here.
Yeah, there is some wind, and there's little clouds that are moving across the sky, and we just hope that one of those little clouds isn't at the wrong place at the wrong time, rather like covering the sun during totality. So fingers crossed. I'm curious to see if the wind changes as the sun goes dark. I'm not sure what will happen, but that's it's still hot right now, but it'll definitely, I feel like it's already gotten a little bit cooler, and it will definitely get cooler as totality comes.
It'll be amazing to see. If the sky stays like this, we'd be in decent shape, but it's too early to call.
Fingers crossed.
Tell us a bit about your first time, Clara.
Oh, yes.
Okay, yes. So my first time was in 2017. That's when a big eclipse passed over a lot of the U.S. And that was what got me hooked. So I thought ahead of time, I'm going to go see this cool thing in the sky. It's going to be really neat. I can cross that off my bucket list. I was completely unprepared for what it actually felt like. And I say felt like because it really isn't something you just see. It's something that you feel, which our eclipse chaser expert friend, Kate Russo, has talked about.
Yeah.
Because like I said, it's not just a visual spectacle. The sky is darkening, the air is getting colder, and it's just a little bit indescribable. But I immediately thought, rather than checking something off my bucket list, I have to see as many of these as I possibly can in my lifetime, because it's a transcendent experience. Now, I'm a hard-headed science journalist. I don't really talk about spiritual transcendent experiences, but it really took me away. I burst into tears. I was not expecting that. It just overwhelmed me. It was overwhelming. And I think that if you can experience that in your lifetime, it's absolutely worth trying to do that and just see what it does to you.
Yeah, I'll put a plug out for, we just released a podcast episode this morning on our podcast Science Quickly with Kate Russo, this eclipse expert who's also on the ground here. And it's just 4 minutes and 25 seconds, which is the length of totality, where Kate will be observing the eclipse, talking about the experience of totality. And she talks about how we experience it above us, around us, and within us. You know, you have what's happening overhead with the sun and with the corona and everything. We have what's happening around us with the temperature and the animals, and then what's within us with, you know, just like this very visceral reaction. She was saying that the reactions, she studies awe in research participants during eclipses, and the experience of awe and fear are physiologically like the same experience, but it's contextual. So you might feel like a primal fear right as totality starts. I've never experienced one, so we'll see how I feel. I don't know. I'm unprepared.
That is definitely part of what affected me, my first experience of it, because I wasn't expecting to feel afraid. And, you know, I knew what was coming. I knew what to expect, and I knew why it was happening. And it still is such an ominous, sort of radically scary experience to have the sun blink off in the middle of the day. It looks like the sun has gone away. And you just imagine people in years past who didn't have a scientific explanation for this phenomenon being genuinely afraid the world was ending. And even today that we do have an explanation, some part of you, your physical body, feels like the world might be ending. And it gives you a rush, a thrill, for sure.
Oh, can't wait.
How can you explain an eclipse to a child? Explain it to me like I'm a child.
Yes, explain it like I'm 5, please, Clara. Take
Well,
it away.
I have a 7-year-old and a 4-year-old, so I have explained it to a child. And so what's happening is that we've got these 3 celestial bodies: the Earth, the Moon, and the Sun, and they're each moving in the sky. But for our purposes, you can imagine the Sun is staying still, right? And the Earth is orbiting around the Sun, and the Moon is orbiting around the Earth. So it's this beautiful dance going on all the time, but on rare occasions, those 3 bodies line up in a straight line, and you have the Earth, the Moon, and the Sun. And now what's so cool about this is that we're just lucky to be able to see an eclipse. It does not happen on every planet with a moon. It's not guaranteed. It's just a pure coincidence that the moon is about 400 times smaller than the sun, but it's about 400 times closer, and that makes it appear to be the same size in the sky. And that's what you need for an eclipse. If it was smaller, you would still see the sun around the edges of the moon, and you would not see totality. And if it was much larger, you wouldn't see the corona. So to see them perfectly aligned is just this gift that nature has given us. And that's what's happening when perfect alignment along that straight line, and you have 3 balls in a row, you see the eclipse.
Yeah, and we'll literally be in the shadow of the moon, which is amazing. And a cool thing that Clara taught me before this eclipse is that we have total solar eclipses now, but we won't always. In a few million years, the moon is slowly moving away from us, and at a certain point, it won't look big enough in the sky to fully cover the sun, and so you'll never have a total solar eclipse again. So we're lucky to live at the perfect cosmic time in history.
We are. We have 620 more million years.
Yes, we're good for a while.
We're
But
good for a while, but we enjoy it while it lasts.
yeah, absolutely.
There are some people outside of the path of totality who want to know what they're going to see. Should they be excited?
Yeah,
Absolutely. So what you're going to see is what we're seeing now, but even more so. It's just going to get more and more. So let me take another check in. Yeah, look at that. So the sun right now looks like a crescent almost. It's not even so much that the moon is taking a bite out of the sun, but it starts to appear that the sun is taking that crescent shape that we associate with the moon. And the moon is slowly creeping more and more over the face of the sun. So you're going to see more and more. And depending on where you are in the country, the more that the moon encroaches on the face of the sun, the more you will also see the sky darken a little bit. The light around you will take on that sort of twilight quality a little bit. And you will notice a few degrees temperature drop as well. And so the really at that maximum approach that you get wherever you are, you're going to see this tiny sun being eclipsed and feel the effects of that around you in your environment.
Yeah, and I've only ever seen a partial, and one of my favorite thing to do during a partial is to go on a walk and just look at the shadows beneath the trees and just see these crescent shapes in shadows and just kind of looking at like the ambient environment around me. I mean, in addition to looking at the sun with Eclipse glasses.
Right.
But
And-
yeah, it's still cool.
I mean, the reason why this is so cool too is not just to see the sun's shape changing, but it's your only chance to see the sun. I mean, I suppose you can look at it any time with Eclipse glasses,
Yeah.
but who really does? So you get to actually look at the sun in a safe way where your eyes are protected, and to see the moon and the sun together and just realize, oh, we're on this tiny little planet adrift in this ocean of space, and these other two bodies around us that we depend on are converging. It just kind of reminds you of these things happening that are so much larger than us, that are going on in the universe that we don't control.
Yeah.
And occasionally they do things that aren't of the usual, and they pull us out of our daily lives and make us think about this cool, awesome planet that we get to live on.
Absolutely. Great time to think about your place in the universe. It's awesome.
Exactly.
The cosmic coincidence. We still have a lot of questions about why the sun and moon look the same size. And then explained it. We can explain it again for folks popping on.
Yes, absolutely. So it's, like I said, it's a pure coincidence because the sun and the moon are not the same size. Obviously, the sun is much, much bigger than the moon, but it's also much, much farther away than the moon. And it just so happens that when you balance out those two effects of being bigger but farther away, and the moon being smaller but closer to us, they happen to appear the same size in the sky. And the size that something appears in the sky just has to do with how far away it is, and also how intrinsically big it is. And we just get this perfect balance where they happen to be the same, so that we get this amazing spectacle.
Right. But there are other types of eclipses. There's an annular solar eclipse. So this is total in that the moon totally covers the surface of the sun, and that's when we get to see the corona and we can take our glasses off and look directly at it. But there's also an annular, not meaning annual, annular meaning, what was that? What is ring, meaning ring? Because you see a ring of light, a ring of the sun's light around the moon. And that's because the moon just happens to look a little bit smaller in the sky during that time because of its orbit.
It's a little bit further away, yes.
It's a little bit further away. And so not every eclipse is a total eclipse.
Yes. And you were asking, why is the moon moving farther away? And that is a cool sort of leftover effect of the moon's formation. So long ago, when the Earth was this very young baby planet, this gigantic asteroid space rock came slamming into the Earth, and it melted a lot of the Earth, and it melted a lot of itself in this fiery collision. And what happened was that part of that broke off and became our moon, and part of it melted into the Earth to be part of our planet. And that's how we got our moon. And ever since that, they've been evolving a little bit, and the evolution is just that the moon is moving farther away. It has to do with the tides, actually. So the moon controls the tides. The tides are sloshing on Earth, and it's affecting the collective angular momentum of the system. And just to preserve that, the moon needs to be moving farther away. So that's what's happening in the evolution of our planet's relationship with our moon.
Is it true that it's starting to move away faster as we get more melting? Is that true, or is that?
I think that's true, but I don't know the details.
We'll get back to you on that. Yeah. But I think there was an article recently. We'll get back to you on that. All right. Yeah. Okay. Well, let's see. What are we looking at right now?
Yeah, let's describe.
We're almost about halfway now.
I would say, yeah.
Yeah, just about halfway. It's so cool. It really does kind of look
like the moon.
Look like the moon when you have your glasses on. And around, everyone seems to be chilling out, have a good time. Sonia has another question.
What equipment are you using to capture the eclipse?
Yeah.
And what can folks do? Can they use their smartphones?
Oh, great question. Actually, another plug. Lucy behind us did a wonderful video for us. You can find on our YouTube about how to capture an eclipse with pretty much any phone you have, with a smartphone, with a basic DSLR camera, or a fancy setup with a star tracker like what Lucy has right now. So what we're using, I believe we have a Sony FX3 camera with a 600 millimeter lens, which is a really long lens. You could use a shorter one and use an extender to try to get closer up to the sun. And the star tracker, basically it aligns with the North Star. And by doing that alignment and knowing the rate of that the Earth turns, it'll keep the lens pointed directly at the sun with the sun in the middle of the frame. So you don't have to mess with the camera. You can set it and forget it. It'll follow the sun. But you can also take images with your phone. Do you have it on hand? You could use.
I don't.
You don't.
Yeah.
There's little solar filters that you can get For your phone, you can also put your solar glasses in
Just
front of
over the camera.
Mhm. I believe so. I believe, yeah, I believe so. We recommend turning off your flash because it'll think that it's really dark once you put your solar filter on top. You won't really get a good photo without a filter in front of your lens. And then you can also try turning on RAW mode so you get higher definition photos and you can zoom in on it later. So don't zoom in super far. You can always crop in afterwards.
Right. And just as it becomes safe for you to view the eclipse with your naked eyes during totality, it also becomes safe for you to just take a picture with your phone as you normally would. So you don't need any special equipment to take a picture of totality.
Yeah, of course you can always take photos of what's happening around you, you know, like you would regularly. I'll also say that right now, I believe right now, there are 2 jets flying overhead on the path of totality, getting a really incredible video, close-up video of the eclipse that we're going to post on our site afterwards. We already did a YouTube video about this project. And basically they're trying to get the highest definition video of a total eclipse and have about 8 minutes of footage, which is obviously more than any one place will get totality. It's because they're moving so fast and chasing the eclipse, that they'll get this like never before seen kind of footage. And we'll be doing research with it, correct?
That's right. That's one of the projects studying the corona and really trying to get at the mystery of why it's so hot and what is happening with the magnetic field to drive this incredible heat in its outer atmosphere.
Right. Yeah. Sonia, do we have any other questions? All right, no worries. I think we'll probably stay on for another 5 minutes or so if anyone has any last minute questions you'd like to ask. And then we'll just dive into the experience on the ground, but we'll leave you with the footage of the close-up of the sun so you can watch it progress. But if you're anywhere near the path of totality or anywhere there will be a partial eclipse, make sure to get outside and view safely, either through the shadows or through your glasses.
Right.
But yeah, definitely take a chance to look at it safely if you can.
And even if you don't have eclipse glasses, like Kelso said, you can look at it through the shadows of a tree or a colander or poke some paper. There's lots of ways to appreciate this amazing experience.
Yeah, I'm really excited to see, like, I don't know. Well, one of the coolest things that I heard, I've heard a lot of cool things about eclipses now, but I didn't realize that when totality happens on the edges of the horizon, it's like a 360-degree sunset. And sunsets are one of my favorite things on the planet.
Totally.
So I'm excited to have this like mysterious wispy white light from the corona and the sunset all around us. I'm so excited.
And it's a good reminder that if you are going to see totality, you'll be tempted to just stare up the entire time, but you should also take a break and look around you. See the sunset, see the crowd, see the animals, just really take the whole experience in all directions.
Cool. All right. I think we're going to leave it there and we'll leave you with a close-up of the sun. Lucy, could you turn us off here pretty quick? Thanks for joining us. This is awesome. We're excited about doing more lives with experts soon. So
wishing you all clear skies.
Yes, clear skies. Good luck and happy eclipse viewing. Nice. All right.